Hi class, today's lesson is lesson 5-3. Today's purpose is to add and subtract mixed numbers with unlike denominators. In the last lesson we used just fractions with unlike denominators and found their sum and difference. Today we're going to add the element of mixed numbers. There's no vocabulary, nor is there an illustration for you to take note of. So we'll go straight to the first example. The first example is a sum. You're looking at the sum of 2 3/4 and 1 1/6. First thing I want you to go ahead and do is to estimate along with me. 2 3/4 is close. It's actually closer to 3 than it is to 2, because that 3/4 is almost a whole. 1 1/6, well, 1 1/6 is closer to 1, because that 1/6 just takes us a little bit over the 1. So we're going to add 3 and 1, which is 4. So obviously our answer to this particular sum will be around the number 4. First thing I'm going to do is I'm going to go ahead and stack these. 2 3/4 plus 1 1/6. Unlike denominators, I've got to find a common denominator, just like the fractions that we did in the last lesson. When I do that, I look at this and I say to myself, well, the least common multiple of 4 and 6 is 24. Well, no, it's not. That's how you would multiply 4 and 6. The least, it is a multiple. 24 is a multiple, but there is a least common multiple. That least common multiple is 12. 4 goes into 12, as well as 6 goes into 12. So now I'm changing these mixed numbers to have denominators that are the same. In order for me to get from a 4 to a 12, I multiplied by 3, so I need to multiply the top by 3 as well. So I'm multiplying by 3 over 3, and that's 9/12. In order to get from a 6 to a 12, I multiplied the bottom by 2, and so I'm going to multiply the top by 2. I'm multiplying by 2 over 2. 1 times 2 is 2. Now my problem is 2 9/12 plus 1 2/12. Well, that equals, first of all, I'm going to add the fractions. 9/12 plus 2/12. 9 plus 2 is 11, so I get 11/12. The denominator stays the same because I've got the same denominator. And then I add the whole numbers. 2 and 1 is 3. So I get 3 and 11/12. Now, if I did go about this and I just found the multiple rather than the least common multiple, I would still get the same answer in the end. If I said instead of finding the least common multiple for 2 3/4 and 1 1/6, I merely multiply the denominators together to get 24 as a denominator, I would still get the same answer in the end. I'm going to add the 2 up here and the 1 here. So what did I multiply times 6 to get 24? Well, I multiplied it by 4. So 4 times 1 is 4. What did I multiply times 4 to get 24 here? I multiplied by 6. So I'm going to multiply the top by 6. 3 times 6 is 18. Now I'm going to do the same sort of thing. 18 plus 4 is 22, and my denominators remain the same. My whole numbers, 2 and 1 is 3, and 22 24s. What I need to do with this fraction, however, is I need to simplify. So I'm going to divide the top by 2 and divide the bottom by 2 because they're both even numbers. And I get 22 divided by 2 is 11, 24 divided by 2 is 12, and then I still have that 3. I get 3 and 11/12. Okay, so you could actually choose any multiple of 4 and 6 that's common to both, and you would get the correct answer after simplification. We look for the least common multiple because it saves us a step. Okay, in the simplification process. Let's take a look at the second example. Second example is just finding the difference. We're going to go about doing the same thing here. 8 2/5 is closer to 8 than it is to 9. 6 3/10. 3/10 is not even halfway to a whole, so we're going to just leave that at 6. 8 minus 6 is 2. And you'll notice that our answer is going to be pretty darn close to the number 2. Go ahead and stack them. 8 2/5. Subtract 6 3/10. 2/5, 3/10. Least common multiple of 5 and 10 is 10. So what I'm going to leave B is this 6 3/10. It already has a 10 as a denominator. What I have to do is I have to change the 8 2/5. So what did I multiply times 5 to get 10 as a denominator? I multiplied by 2, so I need to multiply the top by 2. 2 over 2. 2 times 2 is 4. So now I have 8 4/10 minus 6 3/10. Subtract the fractions first. 4 minus 3 is 1. The tenths stay the same. Then 8 minus 6 is 2. 2 1/10. Is that close to 2? Absolutely. Now, well, you saw the mistake. I should have cleared that example out. It's the same as the previous example, so I'm going to go straight to complete the problem. Here's what you need to do. Tell what mistake was made when subtracting 2 1/2 from 5 3/5 gave the following result. 5 3/5 subtract 2 1/2 equals 3 2/3. How do they do that, and why is that incorrect? Then I want you to go ahead and find the actual answer. And the second problem is tell how you know that 5 1/2 subtract 3 1/4 is greater than or is more than 2. All right, we'll see you in class.